So in the previous class, we have discussed RK method of fourth order, solution of second order differential equations by RK method of fourth order. So in today's class, so we'll solve few more examples on RK method of fourth order, right? So before that, so formulas of this RK method. So we need to calculate, or our objective of this RK method is to calculate y of x naught plus h if it is required y dash of x naught plus h, or else z of x naught plus h. So we have k1 is equal to h into f of x naught, y naught, z naught, and L1 is h into g of x naught, y naught, z naught, and k2 is h into f of x naught plus h by 2, y naught plus k1 by 2, z naught plus L1 by 2, and L2 is h into g of x naught plus h by 2, y naught plus k1 by 2, z naught plus L1 by 2. K3 is equal to h into f of x naught plus h by 2, y naught plus k2 by 2, z naught plus L2 by 2. So L3 is equal to h into g of x naught plus h by 2, y naught plus k2 by 2, z naught plus L2 by 2. And K4 is h into f of x naught plus h, y naught plus k3, z naught plus L3. And L4 is equal to h into g of x naught plus h, y naught plus k3, z naught plus L3. Thus, y of x naught plus h is equal to y naught plus 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4. If it is required, so y dash of x naught plus h, or else z of x naught plus h is z naught plus 1 by 6 L1 plus 2 L2 plus 2 L3 plus L4. And here we are converting second order ordinary differential equations into two first order first degree simultaneous equations, and we are solving that equations, right? Now, third example, already yesterday we have discussed two examples. So today is third one. Compute y of 0.1 given d square y divided by dx square is equal to y cube, and y is equal to 10, dy by dx is equal to 5 at x is equal to 0 by Runge-Kutta method of fourth order, right? So first step, so you convert this second order ordinary differential equations into two first order simultaneous equations. So for that, substitute. These steps are common for all the examples. Putting dy by dx is equal to z and differentiating with respect to x, we obtain, so derivative of dy by dx is d square y divided by dx square. So this is equal to dz by dx. So given equation becomes dz by dx because d square y by dx square is there. So in place of this, dz by dx is equal to y cube. X naught is 0, y naught is 10, and y dash naught or y naught dash. So this will be what here? 5, or y we have taken here y dash as a z. So z naught is equal to 5. Now we have f of xyz is equal to z. So it is fixed, and g of xyz is equal to y cube. We have here two first order first degree simultaneous equations with initial conditions. X naught is equal to 0, y naught is equal to 10, z naught is equal to 5, and h, how to find h? So h is equal to x1 minus x naught, 0.1 minus 0. So this is 0.1. Now we shall compute k1 L1, k2 L2, k3 L3, k4 L4, and finally y of x naught plus h we need to calculate. So first, K1. So K1 is equal to h into f of x naught, y naught, z naught. So x naught is 0, y naught is 10, z naught is 5. So K1 is equal to h is 0.1, f of 0, 10, 5. So in place of x, 0, in place of z, in place of y, 10, in place of z, 5. So f of x, y, z is 5. f of xyz is z. So in place of z, what we have here? 5. So substitute z as a 5. So 0.1 into 5. So this is equal to 0.5. So this is K1. Now find K2. Sorry, L1. So L1 is equal to h into g of x naught, y naught, z naught. So h is 0.1. G is a function. So x naught is 0, y naught is 10, and z naught is 5. So g of x, y, z is y cube. So y is 10. So 10 cube. 0.1 into 10 cube. So this is multiply these two. We'll get this as 100. Now find K2. So K2 is equal to h into f of x naught plus h by 2, y naught plus k1 by 2, z naught plus l1 by 2. So K2 is equal to 0.1 into f of x naught is 0, h is 0.1, 0 plus 0.1 divided by 2, y naught is 10, k1 is 0.5. So 10 plus 0.5 divided by 2, z naught is 5, l1 is 100. So 5 plus 100 divided by 2. So x naught plus h by 2 is 0.05, y naught plus k1 by 2 is 10.25, z naught plus l1 by 2 is 55. Now f of x, y, z is z. In place of z, what we have here? 55. So 0.1 into 55 is 5.5. Now L2 is equal to h into g of x naught plus h by 2, y naught plus k1 by 2, z naught plus l1 by 2. So already we have calculated while finding k2. So here we'll get x naught plus h by 2 as 0.05 and y naught plus k1 by 2 as 10.25 and z naught plus l1 by 2 as 55. Now this equal to g of x, y, z is y cube. So y is here 10.25. So 10.25 raised to 3 into 0.1. So L2 is equal to 107.7. So this is L2. Now calculate L3. So K3, so calculate K3. So K3 is equal to h into f of x naught plus h by 2, y naught plus k2 by 2, z naught plus l2 by 2. X naught is 0, h is 0.1 and y naught is 10, k2 is 5.5, z naught is 5 and l2 is 107.7. So we'll get this as x naught plus h by 2 as 0.05, y naught plus k2 by 2 as 12.75, z naught plus l2 by 2 as 58.85. f of x, y, z is z. So in place of z, 58.85. So 58.85 into 0.1 is 5.885. So this is K3. Now find L3. So L3 is equal to h into g of x naught plus h by 2, y naught plus k2 by 2, z naught plus L2 by 2. So here x naught plus h by 2, we got this as a 0.05 and y naught plus k2 by 2 as 12.275 and z naught plus L2 by 2 as a 58.85, right? So here L3 is equal to 0.1 into g of x, y, z is y cube. So in place of y cube, 12.75 raised to 3. So multiply this with 0.1. So we'll get this as 207.7. So K4 is equal to h into f of x naught plus h, y naught plus k3, z naught plus l3. So K4 is equal to 0.1 into f of x naught plus h is 0 plus 0.1. Y naught plus K3 is 10 plus 5.885. Z naught plus L3 is 5 plus 207.27. So we'll get this as F 0 plus 0.1 is 0.1, 10 15.885, 212.27. So this is F of X, Y, Z. But f of x, y, z is z. So z is 212.27. Multiply this with 0.1 because h is 0.1. So we'll get here as 21.227. Now calculate L4. L4 is equal to g of x, y, g of x naught plus h, y naught plus k3, z naught plus L3. Already we have calculated this while finding K4. So L4 is equal to 0.1 into g of 0.1, 15.885, 212.27. So g of x, y, z is y cube. So y is 15.885 raised to 3 into 0.1 is 400.83. So we have y of x naught plus h is y0 plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4. We want here k1, k2, k3, k4 values. So y of x0 plus h, y of 0, x0 is 0, h is 0.1, 0 plus 0.1 is y of 0.1. So this is equal to 10 plus y0 is 10 plus 1 by 6, 0.5 plus 2 into 5.5 plus 2 into 5.885 plus 21.227. So calculate. So y of 0.1 is 17.4162. So this will be the required answer. Now move on to next example. Given y double dash minus xy dash minus y is equal to 0, and with initial conditions y of 0 is equal to 1, y dash of 0 is equal to 0, compute y of 0.2 and y dash of 0.2 using fourth order RK method. So here what is second order equation here? Y double dash minus xy dash minus y is equal to 0. Y of 0 is equal to 1 means here y is equal to 1 when x equal to 0. Y dash of 0 is equal to 0 means y dash is 0 or z is 0 at x is equal to 0. Now we need to compute y of 0.2 and y dash means we need to find here y dash also. Y dash is nothing but what here? Z, because we are taking to reduce this second order ordinary differential equation into two first order first degree equations, simultaneous equations. So we are substituting y dash as a z. So we need to find here z of 0.2 using RK method of fourth order. So here, so these steps are common, substituting or putting or put y dash is equal to z. So we obtain, so differentiating this, so derivative of this y dash will be y double dash. So this is equal to z with respect to x. So dz by dx. Now we have the given equation becomes here dz by dx because y double dash is there. So dz by dx minus x y dash is z minus xz minus y is equal to 0. I need dz by dx is equal to. So transfer these two from LHS to RHS, minus becomes plus. So dz by dx is xz plus y. Y of 0 is equal to 1 and y dash we have taken as a z. So z of 0 is equal to 0. Thus we have f of xyz as z because it is fixed. We are taking y dash as a z and g of xyz as a xz plus y and initial conditions. So initial, so x0, y0, z0. So x0 is 0, y0 is 1, z0 is 0 and h is x1 minus x0, 0.2 minus 0 is 0.2. Now we need to compute k1 L1, k2 L2, k3 L3, k4 L4. Finally, y of x0 plus h and y dash of x0 plus h or z of x0 plus h 1 by 1. So k1 h into f of x0, y0, z0. So here h is 0.2, f of x0 is 0, y0 is 1 and z0 is 0. So f of xyz is z. In place of z we have 0. So 0.1 into 0.2 into 0 is 0. So k1 is 0. And calculate L1 h into g of x0, y0, z0. So h is 0.2, g of x0 0, y0 1, z0 0 and g of xyz is xz plus y, x 0, y 1, z 0. So xz 0, 0 into 0 is 0 and y 1. So 0 plus 1 is 1. Multiply this with 0.2. So you'll get this as a 0.2. So L1 is 0.2. Now calculate here K2. K2 is equal to h into f of x0 plus h by 2, y0 plus k1 by 2, z0 plus L1 by 2. So K2 is equal to 0.2 because h is 0.2, f of x0 is 0, h is 0.2. Y0 is 1, K1 is 0, Z0 is 0, L1 is 0.2. So X0 plus H by 2, 0 plus 0.2 divided by 2. Y0 plus K1 by 2, 1 plus 0 by 2. Z0 plus L1 by 2, 0 plus 0.2 divided by 2. So calculate K2 is equal to 0.2 F of 0.1, 1, 0.1. So f of x, y, z is z. In place of z, what we have here? 0.1. So 0.2 into 0.1 is 0.02. So this is K2. Now find L2. So L2 is equal to h into g of x0 plus h by 2, y0 plus k1 by 2, z0 plus L1 by 2, right? So x0 plus h by 2 is 0.1. Already we have calculated while finding K2. Y0 plus k1 by 2 is 1 and z0 plus L1 by 2 is 0.1. So g of x, y, z is xz plus y. Xz, x is 0.1, z is 0.1. So 0.1 into 0.1 plus y is 1 and multiply this with 0.2. We'll get this as 0.202. So this is L2. Now find K3. So K3 is equal to h into f of x0 plus h by 2, y0 plus k2 by 2, z0 plus L2 by 2. So x0 is 0, h is 0.2, y0 is 1, k2 is 0.02. And z0 is 0 and L2 is 0.202. Now x0 plus h by 2 is 0 plus 0.2 divided by 2. Y0 plus k2 by 2 is 1 plus 0.02 divided by 2. Z0 plus L2 by 2 is 0 plus 0.202 divided by 2. So we'll get K3 as 0.2 into f of 0.1, 1.01, 0.101. F of x, y, z is z. So z is 0.101. Multiply this with 0.2. We'll get here as K3 as 0.0202. So this is K3. Now find L3. So L3 is equal to h into g of x0 plus h by 2, y0 plus k2 by 2, z0 plus L2 by 2. Already we have calculated while finding K3. So x0 plus h by 2 is 0.1, y0 plus k2 by 2 is 1.01, z0 plus L2 by 2 is 0.101. So g of x, y, z is xz plus y. So xz 0.1 into 0.101 plus y is 1.01. Multiply this with 0.2. We'll get L3 as 0.204. Now K4 is equal to h into f of x0 plus h, y0 plus k3, z0 plus L3. x0 is 0, h is 0.2, 0 plus 0.2, y0 is 1, k3 is 0.0202, 1 plus 0.0202, z0 is 0 and L3 is 0.204. So 0 plus 0.204 will get here as K4 is equal to 0.2 into f of 0.2, 1.0202, 0.204. F of x, y, z is z. In place of z, 0.204. So 0.2 into 0.204 is 0.0408. So this is K4. Now calculate L4. So L4 is equal to h into g of x0 plus h, y0 plus k3, z0 plus L3. So x0 plus h is 0.2 because 0 plus 0.2 is 0.2, y0 plus k3 is 1.0202 and z0 plus L3 is 0.204 because we have calculated while finding K4. So here x0 plus h is 0.2, y0 plus k3 is 1.0202, z0 plus L3 is 0.204 and g of x, y, z is xz plus y. X is 0.2, z is 0.04 plus and here y is 1.0202. So calculate and simplify, multiply with 0.2, 0.2122. So this is L4. Now we need to calculate y of x0 plus h. So x0 is 0, h is 0.2. So y of 0 plus 0.2 is 0.2. And similarly z of 0.2. So y of x0 plus h is y0 plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4. And z0, z of x0 plus h is z0 plus 1 by 6 L1 plus 2 L2 plus 2 L3 plus L4. And here y of 0.2 is 1 plus 1 by 6, k1 is 0 plus 2 into k2 is 0.02 plus 2 into k3 is 0.0202 plus k4 is 0.0408. So calculate y of 0.2 is 1.0202. Similarly, we need to calculate y dash of 0.2. Y dash is nothing but Z because we have taken Y dash as a Z. This is nothing but Y of 0.2. So this is 0 because Z naught is 0 plus 1 by 6. L1 0.2 plus 2 into L2 0.202 plus 2 into L3 0.0204 plus L4 is 0.2122. So calculate Z of 0.2 or Y dash of 0.2. This is 0.204. Thus we have Y of 0.2 is 1.0202 and Y dash of 0.2 is 0.204. So this is required solution. Now move on to next example. Last one using RK method of fourth order. Given d square y by dx square is equal to 2 dy by dx minus y and y of 0 is 1, y dash of 0 is 2. Evaluate y of 0.1 using RK method of fourth order. So what is given? Second order ordinary differential equation with initial condition is given. Y of 0 is equal to 1 means compare with y of x naught is equal to y naught. So x naught is 0, y naught is 1. Similarly, y dash of 0 is equal to 2. So compare this with y dash of x naught is equal to y naught dash. So y naught dash is what here? 2. So what is given here? Second order ordinary differential equation. Convert this into to first order first degree ordinary differential equation, right? So for that substitute dy by dx is equal to 0. So these steps are common for all the examples. So differentiating with respect to x, we obtain, so derivative of dy by dx is d square y by dx square. This is equal to dz by dx. Now the above equation becomes, so in place of d square y by dx square, dz by dx. So dz by dx is equal to 2y dash, 2y dash or 2 dy by dx. Both are same. So we have taken dy by dx as what here? Z. So we'll get here as 2z minus y. And y of 0 is equal to 1 and z of 0 is equal to 2 because we have taken y dash as a z. Thus, we have f of xyz is equal to z, g of xyz is equal to 2z minus 2z minus y. X naught 0, y naught 1, z naught 2, and h is x1 minus x naught, 0.1 minus 0 is 0.1. Now we shall compute the following. K1 is h into f of x naught, y naught, z naught. So h is 0.1, x naught is 0, and y naught is 1, and z naught is 2. F of x, y, z is z. In place of z, what we have? 2. 0.1 into 2 is 0.2 over. Now L1 is equal to h into g of x naught, y naught, z naught. X naught, y naught, z naught is 0, 1, 2, right? G of x, y, z is 2z minus y. Z is 2, y is 1. So 2 into 2 minus 1. 2 into 2 minus 1 is 4 minus 1, that is 3. Multiply this with 0.1. So we'll get L1 as 0.3. Now calculate K2. K2 is h into f of x naught plus h by 2, y naught plus k1 by 2, z naught plus L1 by 2. X naught is 0, h is 0.1, y naught is 1, k1 is 0.2, z naught is 2, L1 is 0.3. So x naught plus h by 2 is 0 plus 0.1 divided by 2, so that is 0.05. Y naught plus k1 by 2 is 1 plus 0.2 divided by 2, so this is 1.1. Z naught plus L1 by 2 is 2 plus 0.3 divided by 2, so this is 2.15. So this is f of x, y, z. In place of x, 0.05. In place of y, 1.1. In place of z, 2.15. So f of x, y, z is z. So in place of z, what we have here? 2.15. 0.1 into 2.15. So this is 0.215. So this is K2. L2 is equal to h into g of x naught plus h by 2, y naught plus k1 by 2, z naught plus L1 by 2. So x naught is 0, h is 0.1. So calculate x naught plus h by 2 is 0.05, y naught plus k1 by 2 is 1.1, z naught plus L1 by 2 is 2.15. But g of x, y, z is 2z minus y. Z is 2.5. Multiply this with 2. Y is 1.1. So multiply this with 0.1. We'll get this as 0.32. So this is L2. Now calculate L3. Sorry, K3. K3 is equal to h into f of x naught plus h by 2, y naught plus k2 by 2, z naught plus L2 by 2. X naught is 0, h is 0.1, 0 plus 0.1 divided by 2. Y naught is 1, k2 is 0.215, 1 plus 0.215 divided by 2. Z naught is 2 plus L2 is 0.32 divided by 2. So calculate, we'll get this x naught plus h by 2 as 0.05, y naught plus k2 by 2 as 1.1075, z naught plus L2 by 2 as 2.16. Now f, here f is missing, please correct this. So f of xyz is z. So z is 2.16. So 0.1 into 2.16. So calculate 0.216. Now L3 is equal to h into g of x naught plus h by 2, y naught plus k2 by 2, z naught plus L2 by 2. So already we have calculated while finding k3. So x naught plus h by 2 is 0.05. Y naught plus k2 by 2 is 1.1075. Z naught plus L2 by 2 is 2.16. Now L3 is equal to 0.1. G of xyz is G of xyz is 2z minus y. So z is 2.16. So 2 into 2.16 minus y is 1.1075. Multiply this with 0.1. So L3 is equal to 0.32125. Now find K4 L4. So K4 is equal to h into f of x naught plus h, y naught plus K3, z naught plus L3. So K4 is equal to 0.1, h is 0.1 into f of x naught plus h, 0 plus 0.1, y naught plus K3, 1 plus 0.216, z naught plus L3, 2 plus 0.32125. So calculate f of x naught plus h is 0.1, y naught plus k3 is 1.216, z naught plus L3 is 2.32125. So but f of xyz is z. So 0.1 into 2.32125 is 0.2321. So this is K4. Now find L4. So L4 is equal to h into g of x naught plus h, y naught plus k3, z naught plus L3. So L4 is equal to 0.1, g of x naught plus h is 0.1, y naught plus k3 is 1.216, z naught plus L3 is 2.32125. So L4 is equal to 0.1 into 2z, 2 into 2.32125 minus y is 1.216. So calculate 0.34265. Thus y of x naught plus h is y naught plus 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. This is equal to y of x naught plus h. Y of x naught is 0, h is 0.1. So 0 plus 0.1 is 0.1. So we need to calculate here y of 0.1. So this is equal to y naught 1 plus 1 by 6 k1 0.2 plus 2 into k2 0.215 plus 2 into k3 0.216 plus k4 0.2321. So calculate. So y of 0.1 is equal to 1 plus 0.2157. So y of 0.1 is 1.2157. Thus y of 0.1 is 1.2157. So this is required answer. So this completes your RK method of fourth order. So here solution of second order ordinary differential equation by RK method. So we have completed here. So next class Monday, so we'll start the solution of second order ordinary differential equations by Milne's correct predictor and corrector formula. Right? Thank you.